So let's have a talk about what ions are and ionization, which is the process of making an ion. So an ion is an atom which is charged, and this means it has an imbalance of electrons. So it has either more electrons than protons or less electrons than protons. So it's not quite neutral. Now, if it's a positive ion, we call them cations, and negative ions we call anions. And just while we're at it, positive ions tend to be metals, and anions tend to be non-metals. Basically, ions form by giving or receiving electrons to achieve a stable outer or valence shell. So there's a few new words there. Valence shell just means outer shell. Okay. Now, when it's giving or receiving electrons, it's trying to achieve 8. Remember, it's got the octet rule, so it's trying to achieve 8. So it will either gain or lose electrons depending on which is easier. So if you've got 6 electrons in the outer shell, it's going to be easier for you to take on 2 than it will for you to lose 6. So you will have a valency of, you will gain 2 electrons, which means you will have a valency of -2, because your imbalance will be that you have 2 more electrons than you do protons. And what we see over here with our sodium is here's sodium and here's a chlorine. Now remember, cations, which are positive ions, anions are negative ions. The anions tend to be non-metals. Cations are metals. Okay, so here the cation loses an electron. Okay, so just let's have a look at the numbers for a second while we start. It has 11 protons in sodium. So 1, 2 electrons. There's 8 electrons more, so that's 10, 11. There's 1 in that outer shell. It is easier for this sodium to lose that electron than it is to gain 7 more. Now chlorine, if we have a look, has 1, 2, 3, 4, 5, 6, 7 electrons in the outer shell. Okay, this means it's got 9 electrons all over and 9 protons, so it's neutral, so it will gain electron to get that stable outer shell, because basically it is easier for it to attract 1 electron to it than to lose 7. So here's what happens. So they come close to each other and the sodium loses its outermost electron. Remember, it's harder to hold on to something if it's further away. Outermost electron to the chlorine. Then we now have what we call a sodium ion and a chlorine ion. And this is the way of drawing them. Okay, so here's your sodium, and we draw a little plus out there. Chlorine, we draw a little minus there. Now this is the way we'll draw it. We'll have a look at this in our next video about Lewis dot structures. If you're not sure what a Lewis dot structure is, feel free to look that up now. You have sodium here, and you see its outer shell is now empty, and it has a positive, a +1 charge. Here we see chlorine, and it has a full outer shell of 8. But you'll notice that this one is different, and that's because it comes from this sodium. So it was over here as a little x, and that moved over there. And now this guy has 9 protons and 10 electrons. 2 in the middle, first shell, and now 8 in the outer shell. And that means it has a charge of -1. So that's what's going on there. So we've got +1, -1. The other thing you'll notice is that they even out. Okay, they cancel each other out. That's what makes it an ion. Now, an ionic compound. If this had +2, then that would be, we would have 2 of these guys. All right. So we draw like this even when it's a solid phase. When we want to draw ions, we draw them like this. So an ionic compound, we draw it like this, even when it's a solid phase. So if we get rid of all this stuff here, this is what it will look like, whether it's in solution or solid phase. So let's just do a little summary about them. Cations, positive charge. Anions, negative charge. Metals, non-metals. These guys lose electrons, that's why they've got a positive charge. These guys gain electrons. Their proton number is greater than their electrons, and these proton number is less than their electrons. Hope that all made sense. If it didn't, ask any questions you have in the comments below. We'll get back to you as soon as we can. Thanks for watching, and we'll see you next time.